Hello, Maurieo! Maurieo reviews Engineering Math Quiz 5. Hello. Well, we're at yet another maths quiz, this time for week 5 as we go through the latest maths quiz. So let's get to the large screen and get on with it. This week we are doubly blessed because we have got a set of model answers from the inimitable red pen expert Stu Ideal, but also from Spaceman. So we'll go through both sets of answers. Each of them give the same answers, but just ever so slightly different. So let's get to the page width just to get a bit more. So first of all, for the graph of the straight line y equals 3x plus 2, y brackets 3x plus 2 equals y minus 1, find the value of the gradient, the y-intercept, and the x-intercept. Now, probably the easiest way to do this, or the easiest way I know to do this, is to put the graph into the form y equals mx plus c, where m is the gradient and c is the y-intercept. And then we're very much in a position to work out the x-intercept with the various tools in that we had. So first of all, we can just write it down in an expanded form. So we get 3x plus 6, 3 times x plus 3 times 2 is 6 equals y minus 1. We'll add plus 1 to each side. 3x plus 6 plus 1 equals y. Just swapping the sides just for convention, y equals 3x plus 6. So we can see there that in the m position, the gradient is 3 and it's plus 3. We can see that the y-intercept is 7 and here. And now to find the x-intercept. Now the x-intercept occurs when y equals 0. When y equals 0, gives us the x-intercept. So we substitute 0 for y in the equation. 0 equals 3x plus 7. And then we can subtract 7 from both sides. We get negative 7 equals 3x. We don't want 3x, we just want 1x. So let's divide by 3. Both sides, what we do to one side, we must do to the other. And there we get x equals negative 7 over 3. And there you are, we have it, filled in all the answers. And that's worth, a number of points. X-intercept. Okay, write down the equations of the following graphs. Now the first graph here is a line graph, and as explained above, it's in the form, well, it can be written in the form y equals mx plus c, where m is the gradient, right, and c the y-intercept. So straight away here we can see that the y-intercept here is 1, okay, and the gradient equals rise over run. It's a negative gradient because it's going downhill from left to right. Okay, so if we look at the rise, we can see here that we've got a rise of 1. And we can see here that we've got a run from here to here of 0.5. And it's a negative gradient, so we put in 1 over 0.5 negative, and we get the answer negative 2. So that gives us y equals negative 2x plus 1 as the gradient of that graph. So now we can check it out in a couple of little situations there. So when x equals 0, y equals 1, which is correct, 0, 1. When x equals 0.5, okay, we put in 0.5, y equals 0, and that gives us that point there. We could check out a third point. We can see that negative 1 here goes to pretty much to 3. So let's try negative 1 when x equals negative 1. Negative 2 times negative 1 is 2, plus 1 is 3. So yeah, it's all looking pretty good. Everything seems to be checking out. So now let's have a look at this next graph here and see what we can make of that. So here it is here. We've got two graphs here, and one of them is a parabola. Now, a bit of analysis of the old parabola. It can come in a number of different, expressed in a number of different ways. First of all, it can be expressed as what we call standard form, which is y equals ax squared minus bx plus c. And then the second form is in factor form, where y equals a x minus r in a bracket x minus s in a bracket. That's factor form. And then we can also have it in vertex form, where y equals a bracket x minus h all squared plus k. So let's start with the easiest one, which is the factor form, and I'm going to start it here. And you can see that you've got, if it crosses the x-axis here at -1, we say that x plus 1 is a factor. It also crosses at x minus 2, so we know that at x plus 2, so that we know that x minus 2 is a factor, and such there. So we can write it in the form y equals a, because we don't quite know how things are going, x plus 1 bracket x minus 2. So that's all very well. And now we look here and we can see that we've got the y and a y-intercept of 4, and that's when x equals 0, y equals 4. So putting that into our equation here, this is going to help us find out what a is. So we've got 4, which is y, equals a, which is as yet unknown. X plus 1, this is when x equals 0, that's going to be plus 1 minus 2. 0 minus 2. So we run that out and we get 4 equals negative 2a. Alright, so we don't want negative 2a, we want a. So we divide by negative 2 and we find both sides, and we find that a equals negative 2. So the answer that we can write down is y equals negative 2x plus 1 minus 2, which we can expand that out if we wish, and y equals negative 2x squared plus x minus 2x minus 2. Collecting our like terms together, we get y equals negative 2x squared plus 2x plus 4. Okay, all right, and that's the two of the forms done here. Now, to get it into the vertex form, we know that that the vertex is always going to be midway between these two here, and the midway between -1 and 2 is 0.5. So what we can do is we can, when x equals 0.5, we can work out that y equals 4.5, and we can that all works out there. So we can write in the factored form y equals negative 2 bracket x minus 0.5 plus 4.5. That's putting it into the factored form, where the h here is the value, the x value of the vertex. There, my h is that there, and the 4 and k is the 4.5. So that's there. So we can check that out, and you can see there that by checking that out, when y equals 0, 0 equals negative 2 x minus 5 plus 4.5. We can take the 4.5 over to both sides, put the 4.5, change the sign of things, just multiply everything by negative, divide by 2, and then we get divide both sides by 2. 2.25 equals x minus 0.5 all squared. Take the square root of both sides, we get plus or minus square root of 2.25 equals x minus 0.5. The square root of 2.25 is 1.5, so we get x equals 0 plus 1.5 or 0 minus 1.5, which gives us x equals negative 1 or 2. So these are just a little process that we could go through just to check everything out and just to show how they all fit together and relate. So they're all acceptable answers that you could use for that graph. Getting this one here probably is getting it through one of the other answers. So getting this one directly, well, you could go halfway between there, and then get the 0.5, sort of work a little bit from there. But yeah, so there's 3 different formula for the parabola. Now looking at this graph here, but perhaps the best one, the easiest one to focus on is by far and away in this instance this factor form here, but you must work out what A is. Okay, the cubic graph, very similar to the same thing. We've got our factors here, x plus 1, x minus 1, x minus 2. So we can quickly put them together as the product of the factors with the A, because we're unknown as to the sort of scale of it, as you're right. So, and then we know that when x equals 0, y equals 6 here. So we can substitute back into the equation. 6 equals A, 1 times negative 1 times negative 2. 6 over 2 equals 2A over equals 2. 6 equals 2A. Divide by sides by 2 to find that A equals 3. So we get, therefore, y equals 3, x plus 1, x minus 1, x minus 2, which we could expand out and write in a polynomial form, no doubt. So these here are the 2 graphs. And then finally, we've got this one here, this last one here. Now we should be able to recognize that this is an exponential graph, and it's a graph of exponential decay. So that tells us that it's got a negative up in here. The horizontal asymptote is y equals 0 here, and the y-intercept is at 3. So what we can do is we can try this here, y equals a e to the ae to the bx. But if we recognize our graphs as that's decaying, that tells us that it's negative. So what we know is that when x equals 0, y equals 3. So x equals 0, y equals ae to the bx. So we get 3, y is 3, equals ae b to the power of 0. And obviously then we know that 3 equals a e to the power of 0, because b times 0 is 0. E to the power of 0 is 1. So a equals 3. So we get y, therefore y equals 3e to the bx. Now we're also given this point here. When x equals 1, y equals 0.406. So then we can see, using that one, that 0.406 equals 3EB to the power of 1, because x is 1. So straight off we divide through by 3 just to get e to the power of b, e to the power of b. Take the log of both, divide by 3. Take the log of both sides. So we get the log of 0.406 over 3 equals b times log e. Log e to the base e is 1. So b equals log 0.406 over 3, which, as it turns out, is actually negative 2. So the graph is y equals 3e to the power of negative 2x. So that's a bit of a harder one, but all the information is there. The actual concepts themselves are quite simple, provided you put them together. Now here's Spaceman's model answers, and you can see in the first one it's been done fairly quickly and using the same method. The second one here, the gradient, it's used the gradient method, but also a factor method here, which Stu didn't use, but this is using the factor method, which appears to be the simplest method, particularly for the two graphs below, which Spaceman has used. So what we do is we've got y equals a, and here's our x-intercept, x minus 0.5. So this is a very consistent approach over which will work over all three graphs. So when x equals 0, y equals 1, substituting into the equation, 1 equals a 0.5, 1 equals negative 0.5a, so a equals 1 over negative 0.5, a equals negative 2, and we get the graph y equals 2x, 2 bracket x minus 0.5, which becomes negative 2x plus 1 very quickly if you understand your maths. So once again, we can see the importance of being able to do this basic rearrangement of equations, and very quick fact checking of things is helpful in these test situations, and the speed and knowledge of that comes only with experience and doing lots and lots and lots of these type of equations and things. All right, now for these ones here, and again a consistent approach from Spaceman rather than using quite a number of different approaches, just using the factored form. So we know this is x plus 1, this is x minus 2 here. Notice that's negative, but it's the opposite, and remember this is plus, so it's negative. So we've got 2, we put them together, y equals a, x plus 1, x minus 2. So then again, using this little toolbox, when x equals 0, y equals 4, substituting that into the equation, we get 4 equals a, 0 plus 1, 0 minus 2, so we get which equals negative 2a. So a equals 4 over negative 2, which is negative 2. Putting that all together, y equals negative 2, bracket x plus 1, bracket x minus 2. And that by far the easiest way of doing it, although there are other ways. Here we have another similar but a cubic graph. So we've got 3 factors, and we've got this typical cubic graph here. So remember, that'll be x plus 1 for at the negative 1, that'll be x minus 1 there, that'll be x minus 2 there. Putting them all together in factored form with the a there, then finding a point we know, which is when x equals 0, y equals 6. We get 6 equals 2a, a equals 6 over 2, which equals 3. Put that together into our equation. Y equals 3, bracket x plus 1, bracket x minus 1, bracket x minus 2. And then finally we come to this this graph here. It has a horizontal asymptote at y equals 0. We're going to try a e to the bx, so it's a similar approach as Stu. X equals 0, y equals 3. We can see that substituting for that 3a equals 3, and then substituting again for the 406, we can see that what we get there is x equals 1, y equals 0.406. So 0.406 equals 3e to the bx. Okay, and b is 1, so we get 0.406 over 3 equals e to the b. Take the log of both sides, and we get b equals ln 0.406 over 3, which is negative 2. So then we're able to put everything together, and we get y equals 3e to the negative 2x. And that brings us to the end of the model answers. And so we can go, once again, we go through. Now the thing, I've provided a blank copy of the test on the course Moodle site. You've got a couple of different ways of answering these questions there, provided by both Stu Ideal and Spaceman. But the key thing to do here is to be able to maybe certainly do your study. Perhaps put your your work down for a side. Go and have a bit of an hour's break or a couple of hours break. Come back, pick up a blank test, and see if you can do it in a reasonable amount of time. Now, there's no point moving on until you can actually answer these questions in a test situation. So you must keep practicing that, see where you went wrong, and get it working, so that every time you see that question, you can answer it in a nice set way. I think it's key to this in this particular instance here is the use of this factored form here, and that works in all three circumstances. Despite there being other ways of doing the answers, the use of the factored form method is very consistent across all of the three major graphs there. And then the exponential graph, well, that you need to do that. But the key is to be getting lots of experience. The more of these you can do and nail and do, without reference to notes and things like that for the exam situation, the stronger you're going to be, the more confident you're going to be, and the better position you're going to be in to pass. So let's just leave it all there. Cheers! See you!